I got cut off again. Nothing's more frustrating than talking to yourself and not even being recorded. All right, so what I was saying was the difference between stratified and cluster. So with stratified, you're split into groups, right? But you're not surveying every freshman. You're not surveying every sophomore. With a cluster, you randomly select the cluster and survey everyone in that cluster. So if we were doing cluster sampling up here with the student council survey, we'd randomly select either freshman, sophomore, junior, or senior, and once we randomly selected a cluster, we'd survey everyone in it. Now with this one, we're randomly selecting a flight and then surveying everyone in the flight, which is a cluster sample. All right, systematic random sample. Members of the population are put into the same or to some order. A starting point is selected at random, and every nth member would be selected in the sample. So this sounds familiar, right? That toll car example where we selected every 10th car that passed through the toll lane. So that would be a systematic random sample. Another example, a principal takes an alphabetized list of student names and picks a random starting point. From that starting point, every 20th student is selected to take a survey. So everyone is the equally likely chance to be selected to take the survey. We pick a random starting point, and then every 20th person after that is selected. All right. Comparing stratified sampling and cluster sampling, when does the randomization take place? We already really addressed that up there. The randomization takes place within each strata for stratified sampling. It takes place to select the cluster. So randomization is still a part of every single one of these samples, which you have to have randomization for a good sample, right? But the randomization is occurring within each strata here, and the randomization is occurring to see which cluster to select over here. All right, so we've got the 4 sampling methods, SRS, which is simple random sample, stratified random sample, cluster sampling, or systematic sampling. So I want you to pause the video, read through these, and try and figure out which one is which, and then hit play, and we'll go over it. All right. So number 1, the police set up checkpoints at randomly selected road locations and then inspect every driver at these locations. This is a cluster sample. We randomly select different road locations, which are my clusters, and then we inspect every single driver at these locations. So that's cluster sampling. All right, the next one. A supermarket wants to study buying habits of their customers. They choose every 10th customer entering the supermarket and conduct the study on this sample. This is systematic sampling, right? If you're choosing every certain customer, that's systematic random sampling. All right, a teacher puts students' names in a hat and chooses without looking to get a sample of 33 students. So this is like my raffle, except I would not get snacks for 33 students. Here is my simple random sample, right? You put names in a hat, you randomly choose 33, that's your simple random sample. All right, the 4th one, if you work for a small company of 1,000 people and you want to find out how they're saving for retirement, you decide that younger employees might have different savings habits than older employees. So you divide the employees into separate age groups. So your age groups are your strata, your stratum, your different groups, right? And you randomly select from each age group. So you'd have a simple random sample in the young and a simple random sample in the older. So this is stratified random sampling. All right. Go ahead and flip the page. All right, we have an example about stratified random sampling, and then we got a lot of AP practice problems. All right, so example 13, a factory runs 24 hours a day producing wood pencils on three 8-hour shifts, day, evening, and overnight. In the last stage of manufacturing, the pencils are packaged into boxes of 10 pencils. Each day, a sample of 300 pencils is selected and inspected for quality. Describe how to select a stratified random sample of 300 pencils. Explain your choice of strata. All right, so what I want you to do is pause the video and give number 1 a try. Just sort of look through it and select what you think should be your strata that would affect the different samples. So I'll give you a minute to go ahead and try that. Okay, I think the strata that make the most sense are my shifts. So I've got number 1, day shift, number 2, evening, and number 3, overnight. Alright, so they're packaged in boxes of 10 pencils each, and a sample of 300 pencils is selected and inspected for quality. So if we have 300, we need to do a simple random sample of 100 pencils from the day shift, a simple random sample of 100 pencils from the evening shift, and then a simple random sample of 100 pencils in the overnight shift. All right, and we could do this through random number generators or the random digit table, something like that, where we'd assign the pencils numbers and go through and select a simple random sample within each shift. All right, our choice of strata. Explain your choice of strata. So, quality could differ based on shift time. Employees working day shifts may have different quality controls than overnight shifts. You'd be more tired, right? You could make more mistakes if you're working the overnight shift. So this would be helpful because you'd be able to see the quality of pencils from each shift. All right, number 2, describe how to select a cluster sample of 300 pencils. Explain your choice of clusters. All right, so go ahead and pause the video and try and come up with your choice of clusters and how you would do a cluster sample with these pencils. So I think that the clusters that make the most sense here is the box of pencils. Right, so once we select a box, we're going to test every single pencil in that box, right? So what we would do is we would take a random sample of 30 boxes and test every pencil in each box for quality. Random sample of 30 boxes, test every pencil. So if there's 30 boxes and 10 pencils in each box, that would give me a 300 pencil sample. All right, explain your choice of clusters. This makes the most sense, right? My explanation would be convenience. Because if there's 10 pencils in a box, then I can choose 30 boxes and test every pencil in that box. It's easier. All right, so explain a benefit of using stratified random sampling and a benefit of using cluster random sample in this context. So my stratified random sample benefit, I would be able to see differences in quality based on shift timing. And that would be helpful from a business perspective, right? So that's my benefit for simple random sampling. My cluster sampling benefit, less time, less cost, and easier, right? So organizing the pencils by shift that produce them might take some extra work on, right? But selecting 30 random boxes by numbering all these boxes and just taking a random sample of the boxes and counting each pencil within it, it would take less time, less cost because of the less time that people spend on it. It's just easier overall, right? So it just depends on what you want to see from a business perspective. Do you want to see the differences in the quality based on the shift timing, or do you just want a general sample and you want to do it quickly and cost effectively? So that's how businesses would make the decision about what type of sampling to use. All right, we are almost done. We just have 4 AP practice problems. So what I want you to do, pause the video, try the first one, and then come back. Okay? So with this one, the director plans to sample student attitudes. He randomly selects 3 of the 12 dorms and sends a questionnaire to all residents within each dorm. That's a cluster sample. The cluster is each dorm. Randomization occurs when selecting 3 dorms. So we randomly select dorms and then interview or survey every single person within the dorm. That's a cluster sample. All right, pause the video, try the next one, and then press play. Okay, hope that you said this was a stratified random sample because our strata here, again, is grade level. It would be important to investigate student depression based on grade level, right? So within each strata, we do a simple random sample. So this is not a simple random sample on the face because we could select out of, let's see, we could select 60 freshmen and 60 juniors, right? But if we divide it in grade level like this, we need to have 30 per grade level, which would mean it'd be stratified, a stratified random sample. All right, flip the page over. You've got 2 more left. Go ahead and pause and try number 15 on your own. Okay, so it's important to identify the population in the sample that's happening here. So the population, and by population I mean intended population. He intends to examine the depth of belief of God among the adult population. So he intends to survey adult population, right? His actual population was all adults attending a certain church that Sunday. That's all we can attribute it to. So let's go through and eliminate everything that's incorrect. It says, which of the following is a true statement? Proper use of chance as evidenced by the simple random survey makes this a well-designed survey. We can automatically say this is not a well-designed survey because his sample doesn't come from the intended population, right? His sample is from all adults who attended a certain church that Sunday, not the adult population. The high response rate makes this a well-designed survey. Again, well-designed? Nope. All right, selection bias makes this a poorly designed survey. We'll keep this in play. The validity of this survey depends on whether or not the adults attending the church are representative of all churches. Does that matter? Our population is supposed to be the adult population, so I don't care that they're representative of all churches. That doesn't matter to me. It's not my intended population. And then E, the validity of the survey depends on whether or not similar numbers are male and female. Again, does not matter, right? I'm trying to generalize to the entire adult population, so C is my answer. All right, go ahead and pause the video and try the last question. Okay, so this question was about school uniforms, right? And they asked the question in 2 different ways. Many educators believe in creating a level playing field to reduce socioeconomic disparities. Do you believe that students should have to wear school uniforms? This is obviously pro-school uniforms because it's talking about breaking down barriers of socioeconomic disparities, right? So this first response is pro. The second one, most sociologists believe that students have a right to express their individuality. So this is anti-school uniforms, right? Because uniforms would not give students a right to express their individuality. So looking at these 2 questions, if you were read this question, you would more likely say yes, right? Because it's the way that it's worded. This one, you would more likely say no, right? So of these questions, 18% favored, while the other question showed 23% favored. Well, if this one's pro, I'm going to say this one's the 23%. And if this one's anti, I'm going to say this is the 18%, right? Because 18% favoring would probably be asked the anti question, and the 23 would go with the pro. So automatically I can eliminate answer choices B, because the first one is 23, not 18. I can eliminate D as well. So I'm left with A, C, and E. Well, I'm going to eliminate C because lack of neutral cluster in the sample, that doesn't make sense with respect to what we're analyzing, right? We're analyzing response bias. Then looking between A and E, this says lack of randomization in the choice of questions. I don't care if these 2 questions were randomized when actually surveying, right? I care that these questions indicate response bias because of the wording of the questions, right? I don't care about the randomization. I know that the wording creates response bias within these 2 questions. So my answer here is E.